All right, it's going.
Okay, this is Chapter 10 review, page 577, number 6, 10, and 12 on the review assignment for Chapter 10. We're going to learn how to do a regression equation, standard error of the estimate, and a prediction interval. So first thing you do is you read the problem, you find your data. We're trying to see if there's a link between the number of grams of protein eaten by vegetarians and their blood pressure. And so we're going to take the grams of protein, which are X, and the blood pressures, which are Y's, and we're going to put those into list 1 and 2 on your calculator. So I'm using a TI-84 Plus calculator. I push stat, enter the data for list 1 and list 2. First thing I want to do is draw a scatter plot. So I can graph those points. You can do it on the calculator, or what's probably easier is just to graph the point 473. So I go over 4 up to 73, put a dot. Over 6.5 up 79, put a dot, etc. And we can see the black points here do somewhat form a straight line with a positive relationship going uphill. So you draw your scatter plot first. The second thing you want to do is find your correlation coefficient to figure out if these values are actually correlated or not. So to do that, you can either use a big formula, but right now I'm going to use a shortcut. On my calculator, I'm going to quit out of these lists, second quit. I'm going to push stat, right arrow over to calculate, go down to choice 8. Linear regression right there. Push enter twice, and here's my regression equation. Now the regression equation, instead of y, we call it y prime in statistics. So that's y prime equals a, there's my a value, plus b, there's my b value, round everything to 3 decimal places, x. So that's my regression equation, which is actually step D on this problem. The R value right here is 0.916. Now we need to see if that gives a strong linear relationship or not. So we know that our R values can range from -1 to 1. 1 meaning they line up in a straight line with positive slope. -1 meaning the points line up in a straight line with negative slope. We're going to look up critical values with table I, which is on the back of your assignment sheet. And we're going to use degrees of freedom of 7 because we have 9 points. 9 minus 2 is 7. The problem tells us to use alpha equal 0.01, and we come up with these two critical values. So because our R value falls between the right critical value and 1, we say there's a strong positive linear relationship. If it would have fallen over here, it would be a strong negative linear relationship. If it would have fallen in the middle, we would have said no linear relationship. Next step, they ask you to make a prediction. If a vegetarian eats 8 grams of protein, what would their blood pressure be? So all you have to do for part F is put an 8 in for X. Type that in your calculator. We have a predicted blood pressure of 86.232. So here's my explanation. A vegetarian who eats 8 grams of protein should have a blood pressure of 86.232. And that's number 6 on page 577. Steps A through F. I guess I skipped over step E. Step E was to draw the line of regression in, or the line of best fit. So that blue line is my line of best fit. Then we move on to number 10. Number 10 tells you to use that same data and find the standard error of the estimate. Well, to get the standard error of the estimate, we're going to use this formula. The sum of y minus y prime squared over n minus 2. Well, to get the sum of y minus y prime squared, one way you can do that is you can use lists. So you can push stat, enter. In list 3, get up on top of L3, type in your regression equation. So I'm going to type in 64.936 plus 2.662. But I don't want to just put an x here, because I don't want to just plug in one x. I want to plug all of the x's into this equation so I can get all of my predicted y's, my y primes. So I need to, right here, put list 1, second one. So these are my grams of protein. These are my actual blood pressures. These are the predicted blood pressures predicted by the equation. Now I want to subtract those two values. So I'm going to subtract list 2 minus list 3, put it in list 4. So go over to list 4, get up on top of list 4, type in list 2 minus list 3. So second 2 minus second 3. So I've got, these are the differences between the actual blood pressures and the predicted blood pressures. They're called residuals. Next, we're going to square all those values because it says squared there. So we go to list 5, get up on top of L5, type in list 4 squared. And then capital sigma here tells us to add those up. So now we're going to take the sum of list 5. So I'm going to get off of this screen, second quit. I'm going to clear that. To get sum, you can push second stat, go over to math, down to choice 5, list 5. So the sum of our y minus y prime squared, so the sum of list 5, is that number, 56.666894. Then we're going to divide by n minus 2. N is 9 points. We have 9 data points. So we divide by 7, then take the square root. We get 2.845. Let's demonstrate that quick. Divide by 7, square root. Whoops. Try that again. Square root of that answer. That's called the standard error of the estimate. It's given the standard deviation of list 3, basically what it's doing. Or excuse me, list 4. It's telling you kind of like on average how much difference there is between the actual blood pressures and the predicted blood pressures. Next we're going to do number 12, which is the prediction interval formula. Prediction interval formula is right here, y prime, and we're going to make a prediction. Let me see here. The question is, find the 95% prediction interval for blood pressure when the number of grams is 8. So, if you plug 8 in for x, we did that over here, we got a y prime of 86.232. To get your t-score, you go to your t-chart, go to 95%, because that's what the question's asking for. Go to degrees of freedom of 7, 9 minus 2, that's your t-score. Your standard error of your estimate would come from number 10, right here. Plug all these values in. To get all these numbers, you can do stat, right arrow, choice 2 variable statistics. And that's where you can get your x bar, your sum of your x's, your sum of your x squareds, etc. Okay? If you type all those in, now I would suggest you type in this first, 9 times 8 minus 7.411 squared, then divide by this entire quantity, then add 1/9, add 1, and then take the square root. If you do that, that comes out to 1.119. So then you have 86.232 plus or minus 2.365 times 2.845 times 1.119. Type that in with a minus, type it in again with a plus. There's what you come up with for answers. 78.703 is less than y, which is less than 93.761. And then you should be able to explain that. The explanation would be that if a vegetarian eats 8 grams of protein, we're 95% confident that that person's blood pressure would be between 78.703 and 93.761. Anybody have any questions? Quick explanation, you can turn it off, Stan.